Hello everyone, welcome back to E2 Tutorial, your go-to channel for making data simple and fun. In today's video, we're looking at subqueries in SQLite, what they are, how they work, and when to use them. Whether you're a beginner or brushing up your SQL skills, this tutorial will give you clear examples and practical tips to master subqueries like a pro. Let's jump right in. Subqueries are SQL queries placed inside another query. They allow us to perform a query within a query, often to filter results, compare values, or calculate aggregate before running the outer query. How can subqueries be used? We could use subqueries in select statements. We could have the from or where clauses included in our subqueries. They can return single value list or single values. They can return a list or even entire tables, depending on the context or the problem you are trying to solve. For today's exercise, you would need the following: a computer, the DBeaver software installed. I would link a video on how to install the software if you do not have it installed on your computer. I like this software because it's free and it has a lot of SQL languages embedded in it, and we're going to be using the SQLite language in DBeaver. You could also download the Chinook data file from my GitHub page, which I would also link in the YouTube description below. And then finally, I always want you to come with a learning attitude. So some of the questions we'll be practicing today to give us an idea of subqueries includes finding all the tracks that are longer than the average length of tracks in the database, write a query to find the names of the tracks that have the highest unit price, list the first name and last name of customers who are from the country that has the most customers, write a query to find the title of the albums that contain the longest track in the database. Now let's switch over to DBeaver and try to perform all of these queries. So here is my DBeaver. I already have the 4 questions we'll be looking at I already have them set up. So we will just go into writing the queries for each of these questions. So as I mentioned earlier, our first question is to find all the tracks that are longer than the average length of tracks in the database. This is a typical example of a subquery. We first have to find the average length of tracks. Then we could use the where clause to try to filter out all the other tracks that are longer than the average length. So, a simple way we could do this is to, write a select statement that says so the reason I have the milliseconds is because if we go to the tracks table on our DBeaver, and view the data, we could see that the column we're interested in is milliseconds because this has the length of each of the songs in the tracks, right? So these are the songs or the tracks, and you can see their composers, and then these are the length, right? And it's in milliseconds. So that's the column we're interested in order to find the length. So we can say select average millisecond. And remember, in my previous video, I talked about what average is, which is an aggregate function. And then we can say from tracks. This gives us the average length as 393,000 milliseconds, right? Or 394,000 milliseconds if we were to round this to a whole number. So, but this is just one query. So we need a subquery that would help us see which tracks are longer than this average. So now I can say, so I'm going to put an asterisk here, but I'll come back and change that. Because the tracks table is what I'm interested in. So now I can come back and change this to, I want the name, the composer, and I want the milliseconds. Okay. So here is our where clause. Remember, we want it longer than, so we use the greater than sign. Then we can copy this. So remember, I'm going to indent this because we want to format it properly. All right. So this is that outer, this is the innermost query. So SQL is going to perform this first, right? It would find the average first, then it would use that average to find out if our milliseconds are greater than it, right? So this is our outer query. So inner query, outer query. So this here is a sub query. SQL is always going to perform the innermost select portion first, which is this, right? So if we run this, now we can see all the songs, the composers, and their length. And remember, this length or this milliseconds is greater than the average. So these are all the songs that their length is greater than the average. So that's how we find all tracks that are longer than the average length of tracks in the database. So let's look at our second question. It says, write a query to find the names of the tracks that have the highest unit price. So this is going to be another subquery. And from the question, you can see that we're still going to be in the tracks table, but now we're interested in another column, which is the unit price. So if we go back to our track data, we're interested in this column, right? This is the column we're interested in. So you can see all of the price for the different songs, right? You could see all of that there. So now we're being asked to write a query to find the names of the tracks that have the highest unit price. So as usual, we could start with the inner query and just see what the max price is, right? So all right, so the max price is $1.99. Let's just say $2, right? That's the max price. So now our goal is to find the names of the tracks that have the highest unit price. Now that we know that the max price is $1.99. So I'm going to put the asterisk, which is a wildcard, but I'll come back and change it. I want to just call the tracks first. So the track table. So I'll come back here and say name, name, and then unit price. I could as well write the name and the unit price without having to put the T beside it, because it will still work. So our where clause, which is unit price. So let me put the T there. So we could copy this and put it in here. Okay. All right. So remember, we're interested in writing a query to find the names of the tracks that have the highest unit price, which was this $1.99, right? So remember, it will take care of the inner query first. Then, based on that, it will try to give us all the tracks that have their price at $1.99. All right, so these are all the tracks that have their price at $1.99. So 213 tracks have their price at $1.99. All right, so that's how we perform that subquery. Okay, so our next one is our next query, or our next question is to list the first name and last name of customers who are from the country that has the most customers. So now we're looking at a different table, which is the customer table. So I'm going to open that. All right. So we're interested in their first name, last name, and country, right? So those are the three columns that we're interested in. First name, last name, and country from the customers table. Okay, so I want to say select first name, last name, and country. And we know that this should be from the customers table. That's where it should be from. Right? We don't need that. Then we want to bring in our where clause, because that would help us filter. And we're going to have another select statement that says country. I will indent that. So list the first name and last name of customers who are from the country that has the most customers. So first of all, we're calling these three columns, right? First name, last name, and country from our customers table. We're trying to filter based on country to find the country that has the most customers. So we select the country, and then we have our from, which is still the customers table. And then we want to group by country, because what we're trying to do here is to look at the country that has the most customers. So we'll group all of those countries together. So let's take, for example, Brazil has the highest number of customers. So we want to group all the customers from Brazil together, right? And then count it in order to show us which country has the highest number of customers. Then we output that result. So we're going to order by count. And then we want this to be descending. So I can close this here. Okay, so if we run this, boom, this is what we get. So what the inner query here does for us is to look at all the countries from the customer table. We group all the countries that have the same customers from all the same customers from the customers from the same country. Would group everything together and count it, right? So we can see here that we have 13 customers from the USA. So if we go to our customer data, we can literally count. So if I go to country, we can count all the USAs, right? And they happen to even be in the same place. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you can see 13. You might be thinking, okay, maybe Canada has more. 1, 2, 3, 4, 5, 6, 7, right? 8. So Canada has 8, right? So that's basically how SQL just helps us to, simplify things. And most times you might have this spreadsheet, this data very long, more than 59, right? And you'll not be able to easily count it the way I've done. So this here just shows us the customers that are from the same country and what country has the most customers. So we could see that all of these customers are from the same country and the USA has the most customers in this database. So that's how we could use a subquery to answer this question. Our last question is to write a query to find the title of the albums that contain the longest track in the database. So we will go back. When you look at this, we're going back to the track table, which is this. So I can close the customer table for now. So we'll go back to the track table. And we're interested in the title. So we're interested in the title, and we have a second table, which is the album. So two tables, album and track. So in the track, we do have the album ID here. So let's open the album table. And we have the album ID here as well. And then we have the title, right? So the title column is in the albums. So we want to see the one that contains the longest track. So which of these albums contains the longest track, which is the length, and that's the millisecond. So we have to combine these two tables together. So let's see how to do that. This is quite an interesting one. So select our first column of interest is the title, and our table is the albums, where So we need the album ID is the primary key in albums, right? So we need to call that because that's how we can join those two tables together. So album ID in so we have our first our subquery. So we have the album ID there, right? From tracks, because remember, we have it as a foreign key in tracks. This is album ID. And then where, because we're interested in the milliseconds, because it helps us to find the length, remember? The milliseconds, that's what we're interested in. So where milliseconds, we want that to equal, so then we have, because the longest track, right? So the longest track. So we want the maximum. So we could use an aggregate function max, right? Milliseconds from tracks. So I will close this here. So this one closes this one here. And I would have a second one. So this first, this close parenthesis closes this one here. And then this one closes everything all the way here, right? So we call this a nested subquery, right? The innermost subquery finds the longest track duration. So this is our innermost subquery here. It finds the longest track duration using the aggregate function max. Then the middle subquery, which is this one, right? That's our middle subquery, finds the albums that contain tracks of that length, right? So all the tracks that meet the max length, and the outer query just returns the album title. That helps us to answer this question, which is to find the title of the albums that contain the longest track, right? And remember, the title is in a different table, which is album, and the track length is in a different table, which is tracks, right? So that's how we put everything together. So if we run this, we can see that Battlestar Galactica Season 3 is the title with the longest track. There's no way you can find out here, right? Because this only has the name and the composer. It doesn't have the title, right? So this table has the title. And if we don't merge the album and the tracks together, we will not be able to find this title having the longest length or being the longest track. So that's how to perform subqueries in SQLite. Thank you and see you in the next video.